So I'm going to be talking today about retention, but really it's deletion and retention. And there's two parts to this talk. After the preamble and take out the conclusion, I'm covering our model for deletion, which is a little bit different to the typical. And then the second part, and I think the most important part, is how we evidence that deletion and how we build editability into that model. So I'll start with this. In the spirit of Laurie Craner's work, I tried to explain my talk to my daughter, who's 8 years old. She gave me a glazed look. Then she thought about knights and treasure and protecting what's precious, and also sorting your rubbish before you throw it out. Two very, very important things to an 8-year-old, and two things that I've tried to embody through the talk. So this is what I'm covering. First, I'll just start with Canva to put us on sort of a flat model of what the real risks are. And I do this because the model that works for us is not going to be the same for everyone else, because we have some quirks that are going to be different to financial services or medical. Then I'll go into our model, how we audit it, and finally a few takeaways. So what's Canva? If you haven't heard of Canva before, we're a graphic design platform. These slides are done in Canva. And we have a pretty diverse product offering with documents or websites or posters, and we do a lot of print work and a lot of hosting. So we don't necessarily hold a lot of demographic information. We don't necessarily hold a lot of your traditional PII, but we do hold a lot of IP. And we have users who are very concerned about creative identity loss rather than personal information loss. So deletion and them saying, I've deleted this, I expect you not to hold it anymore, has some different ramifications to holding an email too long. Now, the size of the platform also matters here because we've got about 250 million monthly active users now, and they're making about 400 new pieces of content every second. And that content changes because probably just while I've been up here on the slide, we've shipped 3 more features, and those features are going to be creating completely different data to what we had yesterday. So the 400 today is going to be very different to the 400 yesterday. And we needed to factor this in when we built our deletion model so that it could evolve as rapidly as the data that it needs to handle is evolving. Now, this is some AI slop, so don't look too closely. This is not our actual policy. But for those who haven't seen a very sort of granular retention policy before, I just wanted to put this up to kind of highlight that different types of data are held for different amounts of time. Some of it we have to hold and we can't delete early. Some of it we have to delete within a certain time period. And these are very, very different requirements, even though they're typically listed as rows in one table. And I personally think it's an act of violence that we all perpetrate on our colleagues when we ask them to read these tables and build systems that comply with them. And I really took that to heart with this in mind. So a couple of things to highlight. 7 years is a really long time. So if you start your audit today, you might not have results for 7 years, depending on how you go about this. And some of these are triggered, what I call triggered, the stopwatch starts, so to speak, when a user does an action, like I deleted my account, so you've got X amount of time to get rid of all that data, or when the data was collected, because we can only hold it for a period of time after it was first initiated. And again, very different patterns, a lot of diversity in this space, and building one solution to handle all of this is tough. Okay, so what model did we go with? We really wanted to tackle this kind of overall at a philosophical solution and begin with the problem space of who should actually be accountable for deleting or retaining the data? Who do we trust to do that? And, spoiler alert, not the service owners, because that doesn't work. And I'll show you why it doesn't work. So this is kind of the traditional naive deletion model. Something like a profile service that handles your settings page where there's the little delete account button. It receives some information, processes it, so deletes the account, whatever that means, and then broadcasts that event to some other services. And those services say, oh, that profile's been deleted, I need to delete my data. And maybe they deleted a design or a poster or an invoice. And they tell another service, hey, I deleted that invoice, so they can delete some information that was associated with it, like a delivery record or a receipt. and on and on and on. And you have these cascading chains. And I'm sure most of you look at this and cringe internally, one, because you've seen it, and two, because you've been burnt by it before. I certainly have. But a couple of the main reasons you get burnt, you end up with mixed policies. So maybe Service 3 can keep data for 3 years, but Service 4 has to delete it in 28 days. And those could change and not necessarily notify each other, assuming they were correct to begin with, which is a big assumption. The second one is you just have cascade errors, where information doesn't pass down the chain, and poor Service 4 here has no idea that Service 1 stopped doing its job. And we have fragmented logs as well. So if you want to collect evidence of deletion, if you want to have some kind of certificate to say that, or a regular audit, that's really difficult when all those services do different kinds of logging. And also just say on the cascading errors, that can go unnoticed, but even when you notice it, it is such a pain to remediate it. Trying to work out what service has to replay, what events at what time, is a nightmare. Okay, so we took that problem space, we said, what are our core concepts to solve it? Now, number one was a star topology. No more of these cascading trees. We want everything coming back centrally. The second one was who should actually be able to trigger a delete. So we came up with this concept of owners. So profile owns the user profile. It owns the delete account button. It's the only one we trust to delete a user. But your marketing platform might have your marketing profile, your revenue platform has your payment. These are objects on their own, and only they own it. And this was important because in the cascading model, this is explicitly put in. I only listen to your service, so I'm trusting you as the owner. But in a star topology, you don't have that necessarily. You don't have pairs, you don't have direct interfaces. The next one was we wanted a standard infrastructure as much as we could for every single participant. And finally, we wanted all the policies and all the keys to be templated, so we could hot swap them. We weren't embedding the policy in the code itself. So a bit of story time here. This was December 2024. This was one of the first diagrams in the original document of like, can we do this better? And we started with this idea of multiple policies with one event trigger in, multiple messages out. So profile says it's time to delete. It only tells a deletion service. And then the deletion service starts the clock. And it sends out one type of delete immediately, which is the immediate delete policy, that row in that table. And then it's the one that waits 7 years, or 12 years, or 2 years, before it sends out another event saying, hey, this is the 2-year warning, or the 2-year policy. The second one was that cascading or chains had to be scalable. So that means when, say, profile says a delete, and the deletion service tells everyone, hey, we're deleting this user. If marketing says, okay, we're deleting this marketing profile, that has to come back in, and then the central service transmit it back out. So we have these hops going in and out, broadcast out, trigger in, broadcast out, trigger in, which scales much better than the branching trees. And finally, replay and recoverability. We wanted the central service to be able to replay any event from any time without talking to the triggers. So if you stuffed up your service, you should be able to get those user delete events back without ever talking to profile. It should all be one-stop shop. So this is just a diagram to describe what I just tried to do with my hands. Profile service sends a trigger in to the deletion service, and then the deletion service broadcasts that back out. Importantly, it broadcasts it back to the profile service as well. And that comes into play with some of the more interesting policies. Now, one service might actually receive that event and action it. The other 3 might filter it, because they don't care about that type of policy. Maybe they're holding payment data and this is, retained for 7 years, so we don't care about the immediate delete. But service 1 does, and it deletes something, and it sends a message back saying, I've just deleted that. Then the deletion service does it again, and on and on and on. So how do we implement this? How do we make this as easy as possible for all those services now that we're sending the messages in and out centrally? We started with this set of parameters. What's your policy? So immediate delete, 7-year retention, whatever. What type of data do you care about? So I delete when users delete, or I delete when payments delete. What table have I actually got in my system? What's it called? And finally, what's the operation to do when you do a delete? And that's enough. That's enough for us to then dynamically generate everything you need between the service database and the deletion service. So we use various infrastructure as code solutions to set up an event queue. It receives those messages, it filters based on that policy and the type, and then it executes that command centrally. Now, how do we audit this? How do we actually know it works? How do we, go to sleep at night feeling like the data is actually doing what it's meant to do? So the old-fashioned model, I won't spend too much time on this, but just to say, being centered on the engineers is the wrong approach. Usually, compliance team comes to them and says, hey, do you delete data properly? Such as by sending them a Google form. And then they go and read the policy and they interpret it, and then they write some code and they try and verify that it actually does what it's meant to do. And that's 3 steps of relying on human subjectivity and judgment. It requires contacting everyone every single time you change that policy, because you don't know what line actually mattered to them and whether it's still relevant and accurate. And it leads to fragmented and opaque implementations, because you don't actually know what they did. And you can't go and check it unless you want to dig into their code. That was way scarier before agents, but still, it's a lot of work. So what we wanted to go to is something that tells us we're compliant today and tomorrow, that has transparent and consistent implementations that we can evidence and rely on, and ideally not burn any goodwill with the service owners. And we centered this on an automated audit solution. So firstly, it needs to know what kind of system it's dealing with. And it actually uses that policy tag from that parameters file and that data type to say, oh, this cares about users and it holds marketing data. Now, with those tags, we can look up a computer-readable policy and know what's meant to happen. And knowing what's meant to happen is a really interesting concept. It actually takes 2 pieces. One's the policy, but the second one is what we call an activity script. Think of that like a user journey. If a user signs up, designs something, orders a print, and then deletes their account, a line in the policy says, for a given system, what should happen at each stage? I should write a record, I should delete a record, I should de-identify a record, or I should retain a record, I should wait 7 years and delete a record, whatever that happens to be. But you need that before you know what's meant to happen. Once you know what's meant to happen, you then need to observe the behavior and assert against it to see if you're matching expectations. And we do that with a full infra-level data capture. I know that's terrifying. I'm not talking about a backdoor to everything, but we scrape the list of resources off our cloud console, and we have a path into every single one of those persistences, every S3 bucket, every DynamoDB, every RDS, and we do a snapshot. And critically, we do snapshots at key parts in that activity script, and we delta them and say, did a record change? Was a record removed? What's the residual after the account's deleted? And because we have all those queues in the deletion service, we can also send a message from audit to deletion saying, hey, for this user, time travel 7 years and send that 7 year now. And we can do the delta before and after and say, would it have kept it for 7 years? Like, not perfect, but pretty close. So finally, we assert those 2 things. We treat that as our verification results, and we send that off to our risk and compliance team. We run this weekly on a little over 3,000 persistent stores. We have about 16 activity scripts now that simulate different journeys, like students or enterprise, people who use AI, people who don't use AI. And out of that, we get a behavior report, and importantly, we get a full evidence log, because we can look at all of those data captures throughout. Now, the data capture, we're currently not running in prod. We're running a mirror of our production stack in a locked environment temporarily. And we do that for the obvious reasons that we do not want a system with a backdoor to all of our production data. But we do want production code, and this gives us that. And the final result is something that looks like this, which is the portal our compliance team can see, which has every instance of a persistence, what kind of retention it's meant to do based on those tags, and importantly, whether or not it passed the test. And we highlight anything that changed from last week's. And we really emphasize that. Like, changing in behavior week to week is actually worse than non-compliance overall in a lot of cases. So key takeaways. We designed for everything here. Like, this is really broad, but we actually built for one thing first. This was a tiny resourced effort to see end-to-end, can we measure one database with one policy, with one journey, with one, and then we started adding breadth. I think any other way this would have never been resourced. We really focused on the crown jewels because you can't do everything, and we picked out the 1 or 2 services that were critical first. We decoupled as much as we could all the policy to avoid that debt. So now we can change the 7-year period to 6 years in the central service. No one has to know anything. And finally, we really played to our strengths here. We have very, very good front-end testing. We have very homogeneous tech. And I think this kind of solution would not work if you don't have those 2 pieces. Finally, this is not just my work. We have a fantastic team behind it. A couple of the names here. Incredibly lucky to have this crew. And finally, thank you for your time.